In this video, we will talk about displacement versus total distance traveled of any given function. So let's start off with the definition of both displacement and total distance traveled. They are similar yet different. So for displacement, it is the distance traveled accounting for direction. However, total distance traveled is also the distance traveled, but it is not accounting for direction. So with these problems, we can think of as an ant is moving to the right if it's positive, moving to the left if it's negative. So for displacement, it states that it is the distance traveled accounting for direction. So for displacement, we would think that it is moving 2 millimeters to the right here, and then it will be moving 1 millimeter to the left over here, which will be a total of 1 millimeter, which is the answer down here. However, for the total distance traveled, we account for all positive areas or directions or distance. So we add the 2 millimeter here with the 1 millimeter to get the 3 millimeter down here. Integral of f of x, which is 2x squared, from a to b, which is the a equals the left endpoint and b is the right endpoint. So this translates into the integral of 2x squared from 0 to 4 dx. So you might have noticed, but since there is no change of signs in between 0 to 4, the displacement would equal the total distance traveled. So to solve this equation, we have the integral of 2x squared from 0 to 4. Using fundamental theorem of calculus, we used the integral of 2x squared and translate it into 2x cubed over 3 and keep the interval of 0 to 4. And then now we use the top minus the bottom, which will put us at 2 times 4 to the cube divided by 3 minus 2 times 0 cubed over 3, which is just 0, into the final answer of 128 over 3 units. If you answered this without units, then you're pretty wrong, because it says up here it is measured in units per minute. So try not to forget about units. So moving on to the second question or example. The question states that if an ant is moving along a bench so that its velocity is represented by the function f of x equals sine of x, measured in millimeters per second, from the interval of 0 to 3 pi over 2, it says to A, find the displacement, and B, to find the total distance traveled. So with this f of x equals sine of x over here, we can graph it, and now we see an area under the x-axis. This is quite different from the example before, because now we have to account for this so-called negative area down here. So with displacement, we just simply use what we did last time and set the integral of fx sine of x from 0 to 3 pi dx into negative cosine x from 0 to 3 pi over 2 using the fundamental theorem of calculus. So this gets us negative cosine of 3 pi over 2 minus negative cosine of 0, which is just plus cosine of 0, which gives us 0 plus 1, which gives us 1 millimeter. A common mistake here will be that some people will forget the 0 down here. Since many of times there will be a value up here and a 0 down here in a function, the 0 would probably become 0. But however, in this case, it is not 0, as cosine of 0 is 1. And this will drastically change the outcome, as 0 plus 0 would be 0, but however, the answer is 1. So with various trig functions and exponential functions, try not to forget the 0 down here. Now, moving on to the total distance traveled. It is quite different, as it does not account for direction. So now we must look at all parts of the area as a positive value. So because we are going to look at all parts of the area as a positive value, we will absolute value the function which will split the integral into two parts. So the first part will be the integral of sine of x from 0 to pi, and the second part will be the integral of sine of x from pi to 3 pi over 2. This is because sine of x equals 0 at pi in the interval of 0 to 3 pi over 2. And it changes sign. So now let's have a minute and try to solve the problem. To solve this problem, we will use fundamental theorem of calculus and apply it to this two sections over here. And then it will become negative cosine of x from 0 to pi plus negative cosine of x from pi to 3 pi over 2. So now we absolute value both of this because we want all positive values in the total distance traveled. So we split these up and we do top minus bottom of both of these, and it'll give us negative cosine pi plus cosine 0 plus negative cosine 3 pi over 2 plus cosine of pi. So now this gives us 2 absolute value plus negative 1 absolute value. So as you can see here is a negative 1, and since total distance traveled will want all positive values, we have to absolute value this specific case right here. So now we get 2 plus the absolute value of negative 1, which gives us 3 millimeters. So with these problems, we can think of as an ant is moving to the right if it's positive, moving to the left if it's negative. So for displacement, it states that it is the distance traveled accounting for direction. So for displacement, we would think that it is moving 2 millimeters to the right here, and then it will be moving 1 millimeter to the left over here, which will be a total of 1 millimeter, which is the answer down here. For total distance traveled, we account for all positive distance over here. So this 1 millimeter of moving to the left wouldn't matter, as it does not account for direction. So we will have 2 millimeters plus 1 millimeter. So the ant would have moved 3 millimeters in total. To conclude my video, I have formulas and helpful tips to help solve displacement and total distance traveled problems. So for the formulas, displacement will be the integral of f of x from a to b dx, and the total distance traveled will be the integral of the absolute value of f of x from a to b dx. So another common mistake is that people usually forget dx or dy, and it's actually a pretty big mistake. So some helpful tips will be that you can use a calculator to find the zeros of some really pretty nasty equations like this. So you simply press second and you press calculate, and then you select 2, which is to find the 0, and then you set the left bound a little to the left and below the x-axis and the right bound above the x-axis, or the other way around, and then you press enter. So now this gets you the x-intercept, which is 0.3537 blah 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 0. This is helpful as now you know where to separate the integral in the interval of a to b to find displacement and total distance traveled. Some other helpful tips will be to test values and try to factor a big polynomial if a calculator is not allowed, in which that is a pretty big probability. So this concludes the topic of displacement versus total distance traveled.